Welcome back everyone, this is going to be our Unit 4 video on AP Computer Science A. My name is Meek and I'm going to be teaching this class way better than your teacher can. So stick along for the ride. The things we're going to be covering here are going to be tips and tricks, or shortcuts, everything you need to know, particularly the topics we're going to be covering: the loops, iteration, while loops, for loops, and nested loops are particularly important for the arrays unit, which is coming in next video. So let's get right into it. First, I'm going to write a while loop for us, and it's okay, we're not supposed to know what that means just yet, but I'm going to analyze it after I write it for you guys. So here I have my while loop. So first things first, I declared a variable I, and I set that integer equal to 0. Okay? Then I have the actual body of my while loop right here. So it starts with the command letter, the command word I should call it, like an if or an else. This designates a while loop. Okay? So that while loop is followed by some parentheses containing a Boolean expression. So this Boolean expression, the computer analyzes it, and if the analysis results in true, if the Boolean expression is true, then it goes inside these curly braces and executes the code inside the curly braces, okay? So this is basically saying, while this command is true, continue executing this code. And that's where the designation while loop comes from, because it's a loop. The code inside the curly braces continues to loop over and over and over and over again until this evaluates to false. Okay? So if we run our program, let's see what it spits out. Okay? You'll notice here it spits out the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it outputted something 10 times total. Okay? And let's compare that with what we should expect from our code. So what is precisely going on here? Okay, the while loop is encountered and it evaluates, hey, I is 0. 0 is less than 10. So I'm going to go inside here and I'm going to execute this code. I++, 0 now becomes 1 because I added 1 to I. So I is now 1. And I printed out I. So the first thing that comes out on my terminal is supposed to be 1, which is in perfect agreement right here. Okay? Next, I reach the end of my curly braces. Now, because this is a loop, whenever we reach the end of the curly braces, we come back to the top and we reevaluate the Boolean. Okay? The Boolean now is I equals 1. Is 1 less than 10? Yes, 1 is less than 10. Let's reiterate through these parentheses. We add 1 to I again, now I is 2, and we print out I. So we should print out 2, as you can see here. And that continues to loop over and over and over and over again until we come out here and now I is 9. We add 1 more. Now our I is 10. We print out 10. And now that our I equals 10, we come back to our Boolean statement, and 10 is no longer less than 10. So once that Boolean expression evaluates to false, we skip over the parentheses and we continue iterating through the rest of our lines of code. Okay, so if, for example, I wanted to print out the word done once the loop is finished, you'd see that this code is executed after this loop finishes iterating. Okay, so understand the sequence and order through which the computer executes lines of code. First, it executes this line of code, then we encounter the while loop. It continues to go back and forth and back and forth and back and forth and back and forth, and it stays in this spot for a while. And once we exit the loop, once this condition is no longer met, we execute the next line of code. Okay? So, and you can see that as we compile our code here. We print out the done that we asked it to back here. Okay? So let's go through another example, okay? How about I declare an integer num. Let me declare it outside. Int num equals 0. And why am I declaring it outside the loop? Because if I were to declare it inside the loop like this, int num equals 0, then in that case it would create 10 variables, okay? So the first time it would create int num equals 0. First time it iterates through the loop, and then the second time it iterates through the loop, it would try to create another variable with the name num, and you would get an error, because you can never create two variables with the same name. Okay, so that's why we need to create our variable outside the loop. And then inside the loop, I'm going to say num plus equals I. So what does that do? It says the num value, and it says num equals num plus I. And I'm going to print out num to the terminal. Let's see what happens then. I get 1, 0 plus 1 is 1, 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, 21 plus 6, 15 plus 6 is 21, and so on and so forth. You take the previous number that was printed out, and you add I to it. You add the current stage of iteration. So 45 plus, now we're on the 10th stage of iteration, plus 10 is 55. And if I wanted to go back and take the average of all those numbers, I could say my total num, because we take an average with total divided by number of participants, and we can say system.out.print num divided by the total number of times we iterated through this. So there's two ways we can go about this. We can either just hard divide it by 10 because we know we iterate through it 10 times, or we can divide it by I, because I also represents the number of times we've iterated through. Because I is incremented by 1, it increases by 1 every time we iterate through the loop. So I represents the number of times we iterate through the loop. Okay? And it's better from a programming perspective to use the variable I in this case, because then if I changes, you don't need to rewrite this line of code. Your program is adaptable, and that's what we want in programming. Okay? On your exams, you are probably going to get a question like this, where should I code it as I or should I code it as 10? Which code is better? And you would say, well, they both do the exact same thing. I don't know. No, it's better for you to use I because I no longer need to change this line of code if I change the number of times I'm iterating. So this, therefore, would produce the average of all the numbers printed out by my iteration. Now you're going to see there's might be a small problem with this, and we're going to discuss that in just a moment. Okay? So what did we do wrong here? We noticed that when we compiled, we got 5 as our average. That surely can't be our average. All of our numbers are so big. Well, that's because we did a little error in our coding. Okay? We said num divided by I. What's num? It is the final value that was outputted. Okay? We don't want the final value. We want the total of all the values. So what should I do here? I'm going to create another int that I'm going to use for my average, and I'm going to instantiate that to 0. Okay? And I'm going to say average plus equals num if I want the average of all the numbers that I just printed out. Okay? So now I'm going to put my average right here, and now when I compile and run, it's going to give me the average of all these numbers here. But wait, there's still another mistake in here. Let's see if we can find it. This one should take us way back to Unit 1 when we covered the division operators. If we do all this math out, it's not going to be exactly 22. So then why did the computer spit out 22? Because we are doing integer division. And the product, or sorry, the result of integer division can only be an integer. Okay? So whatever decimals were part of this answer have been deleted because we need to output an integer. So what I can do here instead is I can cast this to a double. And when I compile and run now, I should get a decimal. Now, it turns out I was completely wrong. Apparently the answer was exactly 22. But aside from that, the point I'm trying to convey to you all is if this was a decimal value, if it was, let's say, 22.2, we wouldn't know because the integer deleted the rest of the decimal places. This could have been 22.2 right here, and we wouldn't know. So we need a double output to ensure that we're not losing valuable decimal places. Okay. Now, from there, let's discuss what is, in my opinion, the superior type of loop, which is the for loop. Okay? So, the for loop, you start with your for, okay? That's telling the computer that you're writing a for loop, and in your parentheses, you have three inputs. The first is you're creating your incrementation variable. Well, this is I that we used in the previous while loop. So we're going to say int I equals 0. We're creating our incrementation variable. Then we're going to set our condition. This was equivalent to what was in the parentheses for the while loop. Under what condition should I execute the code in this loop? And we're going to say I is less than or equal to 10. And the next part is how do we increment? What I could do here is I could put I plus plus, I can put I minus minus, I can put I minus 4. This is just what the computer does to I every time the loop iterates. Now if I just leave this as I tell it just don't do anything to I, leave I alone, it will execute the code in the loop forever. Because if I is 0 and I do nothing to I will forever be less than or equal to 10. So it executes the code in the loop forever, and depending on what compiler you're using, it might crash your computer. So be careful of that. Anyway, now that we've completed our parentheses, we're going to open our curly braces, and then here is going to be the code that's going to be executed every time we go through the for loop. So let me again write a pretty simple for loop where I'm going to increment I by 1 each time, and I'm going to print out to the terminal I. Simple for loop. If I compile and run, you'll notice it iterates through 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Notice how before, if I look back in my command line, we would only iterate 1 through 10, which was 10 outputs. Now we're iterating 0 through 10, which is 11 outputs. What changed? In the previous example, my condition was that I was less than 10 in the while loop. Now in the for loop, I changed my condition. Now my condition is I is less than or equal to 10. So I've added one more iteration to my cycle. So understand how that changed. Okay? I've got a challenge for you guys. Gain access to something where you can write code in Java and do this. Invoke the scanner class, create a scanner object, and ask the user for a word. Okay? And then, using a loop, either a while loop or a for loop, make it such that the computer takes in the word from the user and spits out the word in exactly reverse order. Okay? Pretty abstract, might be a little tough, but go try it and then come back. We're going to work through it right now. Alright guys, so here's our solution. So first and foremost, we do the things that we've covered in a previous video, which is instantiating a scanner object. And once we've instantiated the scanner object, we're going to take that scanner object and we're going to make it collect an input, a string input from the user. Okay? So when we collect that string input from the user, we're going to set that equal to a variable. We're going to store that value in a variable. Okay? And then from here on out is our application of the for loop, of new knowledge to this process. Okay. So first of all, now that I have my word, now that I have my original word that the user supplied me, I'm going to create a second variable. And in that second variable, I'm going to store the reversed word. I'm going to call it rev for rev. And since I am trying to build up the reverse word, I'm going to just declare it as the empty string, first and foremost. Okay? So this for loop is where the magic happens. So remember, the first part of our for loop, up until the first semicolon, is where our counter variable, our increment variable, is declared. So I is yet again going to be our our increment variable. This could be a v, this could be a j, this could be whatever you want. I'm just using I. And for the first instance, at first, I am going to set it equal to the length of our input minus 1. So why am I setting it equal to that? The length of our input minus 1 is going to be the last index in our word. So if I have a word A, B, C, D, the length of that word is 4. There are 4 letters in it. But D is at index 3, because remember we count 0, 1, 2, 3. So D is at index 3. So therefore the length minus 1 is the index of the last letter. So it means that at the beginning, I am starting at the end of the word. I'm starting at index of D right now, okay? And I am going to start at D and work my way backwards. So I'm going to decrement. I'm going to subtract 1 from I during each iteration of the loop, okay? And I'm going to keep doing that until I reach the last index, until I reach index 0. So I'm going to keep iterating through this so long as I is greater than or equal to 0. I have my reverse, my rev, this empty string, and I'm going to say that plus equals reverse plus my original word, the substring I comma I plus 1. Okay? The substring starting at I and ending before I plus 1. So if I start at I, it means this function right here, this method call, gives me the letter, the singular letter at index I. Okay, because recall what we did during our substring discussion 2 videos ago, that the substring method returns a section of the string, section of word, starting at index I, including index I, and ending before the second parameter, ending before I plus 1. So, in order to help us better visualize this, I'm going to tell the system to print out word.substring each time it iterates through this. And I'm going to tell it to print out the rev each time we iterate through this. Let me copy this down. I'm going to print out rev. So now I'm going to compile and run, and let's say the word I want to reverse is rewind. Okay? So first, the last letter of my word is D, and now the reverse is D. And now the second letter of my word is N, or the second from the last, I should say. And now we added that next letter onto the back of rev. So now we're onto the I of rewind, and we're going to add I onto the back of the reverse. Now we've gone through our loop again. Now we're on the W, and we're going to add W to the end. Now we're going to go through our loop again. Now we're on letter E, index E, add E to the end, and so on and so forth, until the rev contains this string, which is exactly the reverse of rewind, and is going to print that out to the user. Okay? So, in order to even further establish what's going on here, I'm going to print out to the user what loop we are on. If we're on the first loop, if we're on the second loop, if we are on the third loop, so on and so forth. So the way I'm going to do that is I'm going to do word.length minus I plus 1. So that means that I'm doing word.length minus I. Actually, in fact, I don't need the plus 1 in this case, because word.length minus I is going to be 1, and word.length minus I on the second iteration is going to be 2, and we'll analyze that later. So if I want to reverse rewind, then on the first iteration of the loop, we have that we're on letter D, and letter D is stored in rev. Then we're on the second iteration of the loop, we're on letter N, and N is added to the end of rev. and so on and so forth. During loop number 3, we land on the letter I, and I is added to the end. And so that is what this line of code right here is doing. It's taking the substring, it's taking the singular character of index I, and it's adding it to our reversal string. And at the end, it prints out that reversal, as demonstrated right there. Okay? So now we're going to move on to another topic that if you understood everything up until now, you're going to find it pretty easy. Okay, this is called nested loops, where you have loops inside loops. So if I have a for loop, int I equals 0, I is less than or equal to, or rather less than 10, I plus plus, and then in there, I'm going to create a second for loop for int j. Now it's important that I'm using int j here because we are unable to distinguish between the I in the outer loop and the I in the inner loop. Again, you can't create variables with the same name. Well, there are very certain situations where you can, but it's easier for both me and you if you just don't create variables with the same name. Okay, there are 26 letters in the English language, and that makes literally billions of names you can give things. So what's going on here? We're iterating through one loop, and inside that loop we're iterating through a second loop. So in order to illustrate this, I am going to declare an integer outside the loop, int output equals 1, and we're going to say output plus plus. So every time the loop is iterated through, we add 1 to output, and then we system.out.print output. Now, let's discuss what is happening here before I compile it and show you the output. Okay? So, we're going to iterate through this loop. Our conditions are met, and therefore we're going to go inside these curly braces, and we are going to execute the code inside of it. Okay? Now we enter inside the curly braces and we find another loop. So we're going to iterate through all the code inside these curly braces 10 times, and then we're going to return back to our outer loop and recheck the condition. Our condition's still true, then we're going to go inside and we're going to iterate through this for loop another 10 times. Okay? So if this loop is iterated through 10 times each time it's executed, and this loop iterates through itself 10 times, then 10 times 10 is 100. We're going to execute this line of code, or these two lines of code, 100 times, and you'll see that when we compile it. I seem to have made a mistake here and put in I where I should have put a J. Okay? This is why coding is very frustrating for a lot of people, because it's the little mistakes like that that you probably never catch yourself doing and always mess you up. So always proofread your code, because you won't get the Oh, it seems I've created an infinite loop. That's not good. That would be my problem. I did the same thing again. There we go. We iterate through 100 times. Why are we starting at 2? I don't want to start at 2. Okay, now we start at 1, and we iterate all the way down to 100. So please learn from my ignorance and stupidity, and don't make the same mistake I did. Don't write I when you meant to write J. Don't crash your computer by entering into an infinite loop. Okay. So that's largely all of what we have to cover in the nested loops unit. I want to remind everyone that we have a Discord server. You come, you join, you come for free, you ask me questions for free. It's a no-brainer. Apart from that, enjoy your life, guys.